write code that is absolutely good for the language that you're writing in, because compilers do a fantastic job at optimizing your code for you. Don't second guess your compiler.
Hello everyone, welcome to Green.io, the podcast for doers making our digital world greener, one byte at a time. I'm your host, Gaël Duez, and I invite you to meet a wide range of guests working in the tech industry to help you better understand and make sense of its sustainability issues and find inspiration to positively impact the digital world. If you like the podcast, please rate it on Apple, Spotify, or your favorite platform to spread the word to more responsible technologists like you. And now, enjoy the show.
Green software. Quoting my dear friend Ismael Velasco, our code is harming the planet, and I am privileged today to have two of the best experts European-wide, and I dare to say worldwide, to deep dive about it. One is based in London, England, and the other in Berlin, Germany. Let's start with Anne Currie. When I think about her, I have this song from Dire Straits, Lady Rider, in mind. Because Anne is a writer indeed, of several science fiction novels, as well as the much-looked-forward O'Reilly book, Building Green Software, with her two partners in crime, Sarah Sue and Sarah Beckman. The book is in early release, and I can't wait to discover the animal which will be finally chosen. Anne and the two Sarah, with and without the H, are also pillars of the Green Software Foundation and are carrying the flag for sustainability in tech in many conferences, like QCon London or API Days Paris, just to name a few. Arne. When I had the pleasure to meet Arne, we went for a walk in a small Berliner park. This is how he likes to exchange, in nature. And during our talk, I was astonished by Arne's deep knowledge on green computing, the articles he shared with me, and his commitment to build efficient tools for developers in a true open source spirit in the startup he created, Green Coding Berlin. As you can guess, both of them are seasoned software engineers having decades of practice behind. Hello, Arne. Hello, Han. Nice to have you on the show today. So I'm going to be super cautious with the pronunciation of your names today, so that everyone will understand when I ask Anne and when I ask Arne to intervene, not to confuse too much or American friends. And I'd like to start with the usual question I ask to all my guests, which is, how did you become interested in the sustainability and in the sustainability of our digital sector in the first place? Did you experience a light bubble moment, or was it more like something that was there forever? Maybe Arne, if you want to start.
Sure. Thank you for the nice introduction. I think the important point is that you already mentioned that I have already been a software developer for quite a while, I think 16 plus years or so. And it was just finished with my former company, which was mostly in performance marketing, advertising, online shops and stuff. So one of these classical Berlin businesses, I would say, at least at the time. And I wanted to make something that has more meaning to me and has a more sustainable touch. So I tried to branch out also in different fields. It wasn't clear if it would be digital or not. And then I got, we have a strong meetup culture here in Berlin, actually, same as in the US, I guess. And I was introduced to a meetup about green coding. So people that claim that they can make the world a little bit better, not only the digital sector, by using software to do it in particular. And on the one hand, it was a bit surprising that you can be a professional in your domain for 16 plus years, and you obviously know that there's stuff like supercomputer optimizations and hardware gets better over time and more efficient. But you didn't even think about, like, in Germany, we have this pro work, like sweeping in front of your own door. So basically just checking whatever you do and if that could be improved efficient in any way. And I got introduced to this meetup group and was, I would say, it kind of had this mind-blowing touch to me that it was like, wow, actually there is so much you can do. And this niche opened up to me, like what I believe green coding still to a certain extent is, that you can get to know very many people very quickly who seem to be the top players who are currently doing what they're doing in the moment, and that there is so much potential to be lifted. Like there's so much to be done you can do with software, so much efficiency gains that are still lying around in the software field. And I immediately knew, okay, this is what I would like to do. And I looked around, and there were not many tools at the time. The tools that I discovered, which kind of had my idea already a bit implemented, was, for instance, greenframe.io, which is still around. And I think it's actually from France, right? And yeah, I picked up the tool and I tried to use it, and it didn't work at all for me, and it was not open source. And then I thought the natural way, okay, I'm going to contribute. But it was not possible. They were not interested. I contacted the support, didn't get a call back, etc. And then I thought, okay, I'm going to re-implement it myself, made the Green Metrics tool, which is one of the main tools we're doing, and said, okay, I want to also do it a bit more professional and be a business and want to make research in this field. And this is where I created Green Coding Berlin, set up a small team of people that I really like to work with. And now we're doing research and trying to make the sector a bit greener.
What about you, Anne?
I've always been very interested in efficiency. And a lot of that comes from the fact that, so I've been in the software industry since the early 90s. And back then, everything had to be efficient. We didn't really have any choice in that. The machines were really terrible, compared to 1,000 times, in many ways, 1,000 times worse, 1,000 times less bandwidth, 1,000 times less power. And so we had to be incredibly efficient in the way we wrote things. So back in the 90s, I worked for a while on the first version of Microsoft Exchange. And these days, one of my co-authors, Sarah Bergman, she works on Exchange, nearly 30 years later. And it's one of the interesting, it's always been interesting to me that that's still effectively the same product, but it requires 1,000 times more resources to do its job now than it did then. And when you look at the world and the energy transition that's going to have to happen, you realize that 1,000 times more resources, that's a lot. And we could really be doing with that, with using that electricity, those resources, as efficiently as we did in the past today. Except there are issues with that. You can't just go ahead and do it. That's the tricky thing to be doing at the moment. How do we align them both? So I wouldn't say I didn't have a kind of an epiphany, a kind of like religious belief that we had to do better. Just the knowledge that we really could, and this is something that has to happen, and therefore we will do it. And this is a key way that we will do it, through increased code efficiency. But it's not the only way, but it is a fundamental way.
The mentor who told me, because I didn't do any software engineering back in university, that is not what I studied, but I learned everything on the ground with a tremendous mentor called Jean-Yves. And he used to tell me about the old days, and he had this expression like, in the old days, we had to break every byte into two. And I was like, it started already to be quite convenient. The computing power were going up, storage was less and less of an issue, etc. But I could not, forget what he used to tell me, like, you need to pay attention to memory resources, you need to pay attention, and we completely lose sight of it. And it's quite fun to hear you referring to these times where resources were super scarce and super expensive, actually. And that actually leads me to the question I wanted to ask you, Anne, first. So I might lose my bet, but I would dare to say that if I bet $1 or €1 or £1 with you, and you choose your currency, that the word green software was not that widespread, I guess, when you started coding. So how do you see the evolution today, and maybe more specifically during the recent years? Where are we? I mean, is it that widespread, or is it more like, or do we live in some kind of informational bubble, on you and I, so that actually we think everybody cares, but that's not that much the case?
No, I think, well, I'll answer your first question first, which is, no, 30 years ago, green software did not exist as a concept for two reasons, really. Software just wasn't that much of a hit on the economy at that point. It wasn't, it didn't use that much electricity. The software industry wasn't that big. It didn't have the impact that it does today. Plus also, culturally, we weren't thinking about these kind of things back then. But ironically, the kind of things that you have to do, or a part of being efficient and using energy well for software, we were just doing because we had to, because we had those terrible machines. So in some ways, we were great because we were doing a lot of the right things, not all the right things, but we were doing a lot of the right things. We had efficiency absolutely down pat. But that was because that was necessity rather than because we actually had to do it. But these days, I think you're right in saying that there's a risk that we're all in a bubble where we think this is something people care about now, but it isn't. But it has become massively, massively more top of mind in the past few years. I remember talking about this at conferences 6 years ago. People looked at you as if you were crazy. And we even got complaints when we ran tracks on this subject a few years back. People saying, well, that's politics. It's not technology. It shouldn't be including it in conferences. But now nobody says that. Everybody knows that it has to happen. There has been, I think that IPCC report really woke everybody up. And the fact that, the tech industry is one of the biggest industries. We have to do things. And some of it is going to be efficiency, just like we did in the 90s. And some of it is going to be time shifting, which is, in the long term, even more important.
Could we say that the awareness has dramatically raised, but what about the practices? I mean, maybe Arne, you want to comment on this one. Did you really see a significant change in the way people code, even if they are aware of the ecological crisis that we are into at the moment?
Part, I think, of every business that everybody does is to do a bit of research of, has this maybe come up before? Like, have people been talking about green coding before? Are we currently on a hype, or are we currently in some kind of a valley, so to say? And if you look back in the academic world, there was already, I think, like 2007 to 2010, there was already very many papers around green coding. There was the university in Texas who had this Marcher supercomputer where you could actually measure all your code. And before even REPL was out there, or I think it was around the same time, which I think we come to technologies later, but let me put it in for the moment that it's a measuring technique in the processor itself. You could already do it on systems that were out there, but then basically nobody was interested anymore, and I would say a drought of papers in the academic world happened, and now it's coming up a bit again, at least in Germany. We have a conference about it, Enviro Info, where it's mostly about computings and ecology in general. So I would say that green coding, at least in my historical view, when I looked at it, has its ups and downs. And now coming back to your particular question, especially I would say in the last year, I wouldn't say that there is necessarily a stronger move on people adopting these techniques. So a measurement you could, for instance, take is one of the most prominent softwares, I guess, like Cloud Carbon Footprint and Scaphandra, I would put out here. Like, how many GitHub stars do they have over time? Like, is there a search or something quickly? Not that I have seen, at least. I don't have all the data as I'm not the repository owner, but this is my view on how green coding has evolved over time. But if it's okay, I would elaborate on this one a bit, because you also asked me about what we're doing and how we see the sector in particular. We at Green Coding Berlin do not necessarily do what people often think about what green coding entails for them in particular. So when we talk to companies or young developers, they ask us for optimizations. So they say, okay, how can I make my code greener in particular right now? Like, which tool do I have to use to emit less carbon? This is actually something we don't focus a lot on particular, because green coding, from my view on, if you look at the digital sector as a whole, is not a problem that is coming from the industry itself. But so the industry doesn't necessarily have an issue with the digital product that it's using. It's rather something that's coming from states as actors, from developers, and from consumers. So the industry itself, in my view, has an incentive to tackle things that they think that are either not efficient enough, like, for instance, the machine learning models, because they cost them a lot of money. So I think this will resolve on its own. There is a bit additional pressure might be nice, but it's not necessarily needed, I guess, for this to transition, or things that are not cost effective. So if you look at something like YouTube, Twitch, and Bitcoin, they are in itself, for the most part of it, they're already cost effective, but people complain about it a lot and think, oh, can we not make this greener in a way? Because they often don't use these technologies themselves. So you will rarely hear complaints about people that earn their money with Bitcoin, that Bitcoin should use less energy, or people that don't use Twitch are more likely to complain that one streamer can emit so and so much amounts of carbon. But for the companies that run them, like Google that runs YouTube, or Twitch that I think is owned by Amazon, it's a cost-effective thing for them to use these platforms. So they will produce an enormous amount of data, which is harmful on its own, but it works for them. So the incentive is there, not that intense. And I think green coding techniques on YouTube will take a bit until they're implemented if they are not directly cost-effective, for instance. On the flip side, the developers are becoming more concerned. So this is what we see, for instance, as a company. But this overlap of business and interest, I think this is still in the making. And I'm not really sure if this is the biggest driver. So I think that green coding and the effect, so coming back to your question in particular, will mostly happen, and this is also what we work at green coding in particular, through regulations. And this means that you have to have the transparency first, and this is what our tools are mostly doing. They are giving developers and users transparency, they make stuff comparable, and then someone can step in, like regulators or society, to force that optimization techniques or limits can be implied.
And how do you enable more transparency to happen when we have so many issues? I'm not going to brag or quote too much during this discussion, Max Schulz from the SDIA, but he's got a point when he says again and again that especially the main hyperscalers are not providing enough comparable and transparent data to truly leverage everything that we could do in computing. So do you also believe that it's an issue, or actually what you were saying is that with the tools that you've developed or the approaches that you encourage people to follow, there is a way to become more efficient, even if some data are missing? And I know that all the hyperscalers are, I would say, not doing things at the same speed, but I will not enter this debate here.
It's interesting with the hyperscalers are interesting because you can put pressure on them. Even obviously governments and things can put pressure on them, but it's amazing how much pressure users, customers can put on them. If you say, look, I want this, I'm demanding better carbon footprint measure, I'm demanding this information. They are quite, AWS, Amazon is quite customer responsive. Actually, Azure is quite customer responsive as well. Google not so much. But if you raise this, if enough customers raise it, and it doesn't require that many, and you keep raising it, they will see that there's customer demand for it, and they will do it. And when Amazon talk about being customer obsessed, they actually are. If you keep raising, if a handful of people, not that many, just keep raising this with AWS reps, we have a good chance of getting it. And we got those sustainability commitments. Whether they will be sufficient in the end remains to be seen. But we have made progress by just getting folk to raise issues with their providers.
I think this is one of the big levers to go to, that you have to put the pressure on the cloud providers, either through the user side or through a regulatory side. And for instance, this is what our tools are trying to do. So a lot of people run an extensive amount of CI/CD pipelines. And what our tools do is that they simply create an easy machine learning model that's based on an open database of energy consumption of servers called spec power. And then you plug that into a bit of code so that it can be digestible by GitHub Actions, this is their pipeline product, or by GitLab CI, this is their pipeline product. And then you just see at the end how much your pipeline is consuming, and you see it for your hundreds or thousands of pipelines that you're having. And then you have a number, at least at the end of the month, and you can see if this number is going up or going down. And then you can go the route that Anne was suggesting and saying, hey, this number is maybe not the best because this company, Green Coding Berlin, is doing it from the outside in. So why don't you give us these numbers? So they go to GitLab and they go to GitHub, or Microsoft in particular, and they say, we want better numbers. It's not so hard for you to give them to us. And now we see that it's possible. So actually somebody can do it from the outside in. So why don't you give us these numbers so we can be better? But we believe that people need to see this to a certain extent until they can even ask the right questions.
It's a bit like starting with the metrics we have to create a momentum, and then in parallel putting pressure to get better metrics and better data from providers. And if you don't mind, both of you, because we could discuss a lot about cloud providers and the general approach, but actually I'd like to deep dive a bit more with you. Could you share the top 2-3 techniques or approaches that you implement, I would say, on almost on a daily basis to reduce carbon or carbon emission caused by software?
I'm a bit controversial on this one, so I'll start off and say, because this is something that came up when we started writing Building Green Software. One of the questions that came up immediately from people saying, "Oh, can you in the book can you cover some examples of efficient code?" And so I used to write efficient code. Almost everybody I know writes efficient code, and we all, this is terrible, we all laughed when someone said this, because the definition of efficient code is it's incredibly custom. It is utterly and specifically custom to the very, very particular use case that you're interested in. And a really efficient code takes ages to write. It is incredibly bad for developer productivity. So generally, it's quite hard to give people advice about how to write efficient code. I mean, you can say, well, I'll use efficient languages like C or C++ or Rust rather than less efficient ones than like Python. But even that's not so clear cut these days, because there are new Python compilers that are compiling Python to machine code or compiling Python to C. So you can still write in the inefficient language and have it transformed into a more efficient one, because they know that developer productivity is really killed by writing this very, very highly custom code. So it's hard to give generic advice. If you speak to folk who are really still writing this efficient code, because if you're, for example, in the networking area, you're still having to write that hyper efficient code the same kind of code that we used to write 30 years ago, because you really, really need that super performance. And their feedback is generally write code that is absolutely good for the language that you're writing in, because compilers do a fantastic job at optimizing your code for you. Don't second guess your compiler. Follow best practice so that your compiler can optimize as far as humanly possible. It's a bit sad because everybody wants to hear some amazing C technique, whatever. But fundamentally, it's just really, really hard and very custom. The best thing you can do is measure different tools, get somebody else to do it for you. Don't custom write your own hyper efficient code. Find libraries and tools that are good and use them, which is what you need to use the measurement for. You need to measure to find out which are the good tools and libraries, and you swap out poor ones for those more optimized ones. But don't attempt to do it yourself unless you are actually writing those libraries, I would say. So it's a bit sad, but I would say there's no killer technique that you can use, because it's all hyper custom. It's all basically arsing around with your L1, L2, L3 caches for a very, very specific use case. I don't know if you might disagree with me, Arne.
No, I actually have the same. I have the notion that we are very on par here with our view where how good these generic optimization tips are. However, I would like to, if you think about what we often get as requests from users who see these articles that Amazon has implemented a new gzip or zlib compression technique in their S3 service, and it saved them, I don't know, I think it was in the tens or in the hundreds of millions. So because they had to use less hard disk to store their stuff, or then you see this article that there's a 70% improvement in React by just stitching the virtual DOM, right? So apparently it is possible on a particular product to get these gains. However, I would very much agree that on a generic level, it's either extremely hard to implement. So there are techniques that are known for many years, like using vector instructions, loop unrolling, etc., that do work if you really put the work in. But it's very questionable if really in the end, if you look at the whole thing, like also the time the developer had to sink in, how much the software will run in the end, how much it cost you building these 50 to 100 iterations until you got it working, if this really saved you something in the final calculation. So I think this is a bigger question, and I think, Gaël, you might make a separate podcast on this, like this whole idea of software life cycle assessment, also something that Max is very passionate about. But I would like to give you our approach on how we typically do it. I think we have the same idea that Anne mentioned, that measuring is like one of the first steps. So when we typically consult with companies or when we do workshops with developers, we have these 5 pillars, so to say. So it's first of understanding. So first of all, people often don't understand the terms that are even used. If you talk about energy and energy efficiency, they don't even know how a network could even cost them energy, that network costs can be linear, or they can be progressive in a way. And then transparency, like then measuring and transparency. So whatever you then have understood and measured, you should also show it to people and make it public. So in GitHub as a badge or something. Then continuity is a pillar we focus on a lot. So it doesn't help you if you look at it one time. So you have to monitor it over time. So the same like the GitOps approach goes, that you have to, with every release, with every build, you basically have to check if your initial measurement or your initial assumptions are still right, or the product is currently derailing and you don't want that. Then the 4th pillar is the comparing. So you should, if you are thinking about software and you're looking in the silver bullet, not the silver bullet, the goal at the end, the optimization, so to actually saving something, comparing is often very helpful. So sometimes just looking at, okay, how much would database 1, just technically identical to the database that I'm currently using, how much would this change? So just swapping libraries out, and the same as you said, or swapping infrastructure out, is often a better way to go than going on code level optimizations in particular. But they are obviously a point. So our 1st pillar is then code level optimizations wherever they make sense. However, this is then specific. So you have to really look into your product. It often means using specialized tools, so maybe VTune or something, or code profiling techniques. So this is very laborsome, and these tools are also sometimes cumbersome, to also put another word in here.
I would say it's a lot about measuring and comparing. So rather than having like one silver bullet, which makes it makes sense. If it was that easy, everyone will do it. And I guess the question of software productivity, I mean, the productivity for your developers is absolutely key here. We need to take into consideration the full life cycle. And like if you take 3 or 4 times, more days to just to release one little piece of code, actually, you could have used the energy better.
And unfortunately, it's more like 10 or 20 or 30 times as long. I remember how long things used to take. They used to take an incredible amount of time. I mean, it is interesting. We've had so much in the 30 years of my career. There has been so much, more than 1,000-fold improvement in machine productivity, and we've used it to make developers more productive. And it's very hard to make the sell to your business that you should go slow down, because you'll go out of business. So it's kind of like you do have to trade off what you can sell to your business, as well as and what's a sensible thing for your business to do, as well as what is the green thing. You have to align them. So I'm not saying throw out the green things. I'm thinking you have to find ways to align them both. And the good news is that all the modern ways of working with microservices, with open source libraries, with hyperscaler services, Arne said this himself, said that there's an alignment, if you're a big business, to make your stuff efficient, because it's so many people are using it. It's worth putting in that 100x developer effort to make it efficient, because you've got so many people using it that pays off. But if you're only a small business and you only have a moderate number of people using your software, you'll probably never pay back that developer effort to make it super efficient. So you're better off just using a library. Don't do it yourself. Use a library, use an open source library, use a hyperscaler service for whom it is worth putting in that effort. But that isn't, I mean, we're talking about code efficiency here, but I'm not even sure in the long run that that's going to be the big win that we're going to make in the tech industry. I think it's going to be the time shifting, because even now we're seeing renewables, you get huge amounts of energy at some times and no energy at others. And that requires a whole different way of using electricity in the old days, when it was just, flick of a switch fossil fuel driven.
So is it something that you implement quite a lot, like chasing the sun, which is a time shifting and location shifting, or not that much?
It is actually a technique we do implement on workshops with developers, because it's generally a very interesting technique to implement, as it suggests that there are immediate gains. I don't know if you've recently read the piece. I'm not sure who wrote it, if it was David Mitton or Adrian Cockcroft, or maybe I might be mixing stuff up, where there was this piece called "Don't Chase the Sun." So it was kind of like a counter-argumentative piece that is, at the moment at least, often doesn't make sense. And I will elaborate on this a bit further, but I would like to say ahead that I generally agree with Anne that this is an enormous saving techniques, and this is actually what, at least in Germany, we are implementing with the grid. I think every country it does, but I can only really speak for Germany, by saying we want to have smart meters so that in the end, when we have surplus energy and we really need to not waste it by curtailing it, we want to charge electric cars to this particular time. And in Germany, we have a long way to go by incentivizing people to charge them at these hours so that it's actually cheaper to wait. So currently at the moment in Germany, it's not cheaper to wait, even if we would have smart meters, because there is a law that makes this, that the pricing even throughout the day. But if you look at the current state of how time shifting works, we're currently implementing a small plugin for GitHub where you can say, hey, I want to run this pipeline at this particular amount of time because the prognosis or the forecast says that there will be green energy at the time. However, how the grid operators, to my knowledge, is that typically they plan out how the grid is supposed to be, and you are very likely, if you're at some point where the forecast says there is a lot of green energy and the grid is already in a stable state, and you demand more, then it will not come from solar because this is, or from a wind farm, because this is then already curtailed, because the grid needs this bit planning ahead. So they will more likely drive the power plant that runs on coal a bit more up. But this is a momentary problem, to my understanding. Like if they learn these signals over time, so even if you do that 5-10 times, the grid will learn it, and then they will actually not curtail the green energy so much, and you will get it. But it's the same as with network savings. It's often not an immediate gain. It's more a theoretical long-term thing until we can understand the signals better.
It was Adrian's article, "Don't Chase the Sun." Yeah. And you wanted to say something, sorry.
I totally agree. On both the don't chase the sun, you don't really want to be moving your data around. What you want to be doing is delaying it, rather delaying jobs rather than moving data around to chase the sun. I agree with both Arne and Adrian on that one. It's interesting. It's what Arne mentioned earlier, YouTube. So YouTube is an excellent example of one of the products that Google used to do their own kind of grid balancing on their hardware. That if you upload a video on YouTube, sometimes it happens. Sometimes you'll notice that it's transcoded very quickly, and sometimes it won't be transcoded for a while. And it's the reason for that is that they use that as one of their latency insensitive workloads. If they've got a lot of stuff that's going on, if the systems are busy, they'll just shove that transcoding. It's a little bit later in the day when things are less busy, so that they get better utilization on their machines. And right now they're working on similar kind of shifting to try and move work to when the sun is shining and when there is potential to power it greenly. But Arne is right that there isn't necessarily an immediate benefit to that, because right now the grids might not have enough green energy to provide that if you because they may already be curtailing it. But in the long run, if you create demand at times when there is potential solar or wind to match it, then more solar and wind will be put in. So it's not necessarily an instant win, but right now it's about the transition. It's about moving to how we're going to work in that new world.
I don't remember if he mentioned also this aspect in his article, but it's also that chasing the sun is actually an issue once you start implementing multi-criteria approach, because carbon is one thing, but water is another. And, if you shift all the workloads in country where you've got plentiful of sun, usually water is pretty scarce. And we are experiencing several droughts here in Europe, and the same goes in the US. So the moment you say, okay, let's chase the sun for green electricity, you might also create a lot of problem when it comes to water stress. So that's also why I kind of like his expression, don't chase the sun. Maybe chase the wind is a bit more accurate. But eventually, I guess it's all about reducing the energy intensity and yeah, don't go for a silver bullet or quick fix that actually does not exist in this energy transition. That's how I understood his main message, and I could not agree more with both of you. If you're okay with it, because we talked a lot about measuring metrics, etc. So could you maybe share a bit, both of you, the do and don't when you measure, and maybe one or two examples on how you manage to measure for some of your clients?
What I see in particular is that people have very often very different setups, which I think is normal if there is if people are trying to find ways how to measure things and there is no standard out there. I think you can separate it in two basic domains. So there is a cloud at the moment, which most of the measurement techniques are not available that we use. So the cloud is typically more an estimation game. So you have pre-measured machines, and I will come to a bit how you do that. So you have basically pre-measured machines. You have something like, you could call it a calibration curve if you want to. So I know it's not technically correct, but for some people this term might mean something. But you basically have a curve that tells you at this amount of utilization, this machine uses this amount of energy. And this curve is typically nonlinear, which requires a bit of a bit more than just a simple m times x plus y, or sorry, m times x plus b. So already getting to the technical stuff, let me go back a little, more than a linear equation to solve this problem. So you need a bit more. So here an easy machine learning model is what we use, for instance, to get this curve, and then you can go into the cloud, where at least the utilization, which is a typical DevOps metrics or a typical monitoring metric that is usually available in many of the products, you can use, and you can to a certain degree assume that the configuration of the machine that you have already measured is very similar to the machine that's in the cloud, as this database where we get the data from are typically machines that are bought by cloud vendors. And they often use standard configurations, not all, but some. And then you can get a reasonable estimate of how much a machine in the cloud would use in terms of energy. So it is also a similar approach that Cloud Carbon Footprint follows. They have a linear assumption to my knowledge, but I haven't monitored it currently or in a while. We have this non-linear one, which is supposed to be a bit better. And I know there are people out there who have even better models, but they are not open source. So how do you even measure it if you're locally? So for a while, and this is also how most of the academic papers have done it, is that people attach a power meter to the computer, which is something that everybody who has done home automation or just wants to know how much his microwave is really using knows. So it's basically an adapter you can put over your power plug. And it will tell you how much this machine that is connected to it is currently using in terms of watts or kilowatt hours, if you want to have more like an energy and not a current power draw. And they have also USB access, they have Bluetooth, so you can easily hook them up in kind of like a connected system that can also then run measurement jobs for people. And what has not recently, but for some people it is still new for developers because it's kind of under the hood, is a technique that is called Intel REPL, or more like a hardware feature, I would say, not a technique. It is something like a power meter inside of the CPU. Actually, it is still more an estimation calculation, but it's very accurate. So very many papers have already confirmed that it's very accurate to their falsification measurements. And what it basically gives you as a developer is you can write Linux code, and there is a function you can trigger or a hook, and then you will get the energy that the CPU is using. So you basically, hey, I'm going to start here. So you make a start point, then you run a bit of code, and then you ask it again, and then you get number B's, and then you have number A and number B, and you subtract them, and then you know how much energy has been using between these 2 points. And what we do for measurement in particular is that we write around these frameworks that already exist. So external power meters, onboard sensors that exist. So there's also techniques like IPMI, which which are also internal power meters, so to say. There is this REPL stuff, and we glue them together in one big open source tool, the GreenMetrics tool, we call these sensors, that can attach these different sensors. And then we give this out as a full-fledged solution to developers that already have software, which typically is now written in container form, already have their setup container files, so something like a Docker Compose file. And then they can just say, hey, please take this Docker Compose file, and then I want you, similar to like a bash script, so like a Linux easy script, and then I want you to run this line, maybe run this node program, maybe run the browser, and then you're finished. And I would like you to tell me in between, like every 100 milliseconds or every 50 milliseconds, I would like you to write down the energy, right? And then at the end, you get all the energy nicely displayed in the graph. There is some statistics applied to it, like has there really been a change from the last time you've tested it to the time you've tested it now? And to make this even better, we then also offer a service on the web for free, where we have a measurement cluster with pre-configured machines that apply best practices, how to measure, and I can elaborate a bit further on them later, but they do exist, and then you get a better measurement, right? It doesn't fluctuate as much. It is more reliable, so you don't need as many repetitions to get a good statistical conclusive answer if the code is really different to another piece of code. And we try to bring it into a tool so that developers can use it with techniques they already know, like starting and stopping containers, or firing up a tool on the command line, and then they get with the onboard mechanisms that already exists, like Intel REPL or using machine learning models through CPU utilization, they already get a metric out. So they don't have to be measurement professionals. They just need to know how to use a Linux tool.
And this is where you can start comparing, I guess, or challenging the use of this library against another and all that stuff that you mentioned earlier.
Yes, exactly. So the way to go would be then just you have a Docker Compose file, and then let's say in one time you use, as a package manager, where you use npm to install everything. You want to see if it goes faster or uses less energy, and then you use pnpm or you use a different one. I think Yarn is also a package manager. And you can see if this library or tooling swap will change anything in your build process or your program.
Arne, you mentioned best practices, and I know that this is something that is very keen to Arne's heart. Could you maybe, Anne, tell us a bit more about these best practices? And Arne, if you don't mind, you might comment on it.
Well, when Arne was talking there, the thing that immediately hit me, and I thought was quite interesting, is in the old days, and it's worth thinking about what we used to do. In the old days, the reason why we did all of this stuff was performance. It was like the machines where, you had to ring every millisecond of performance that you could out of systems. So when we didn't used to measure energy use, we used to measure performance. So you'd time how long every operation took, and that's a fairly good proxy for energy use. How long things take, how performance stuff is. But I was thinking about it when Arne was talking there. But the trouble with it is, it's very custom. If you instrument your code to say, assume when this message comes in to here, and then this message leaves here, how long is that? And if it's less, because how long things take is often about how many CPU cycles it's gone through, and then how many CPU cycles it goes through is basically how much energy you're using. So there's a good correlation between performance and being green, which is why a lot of these kind of highly tuning techniques are still used in networking, where performance is absolutely key. So you've got that. But the trouble with that is it's very specific. It's very custom. It matters. You have to know what an application is doing. You have to know which messages are going through, and where to put your instrumentation in. Whereas if you're just measuring the energy use of a whole system, that's more generic. Therefore, you can have tools that are more generally usable by everyone, rather than doing things that are very, very specific and custom. So I assume that's the reason why we've moved over from using performance as the key kind of way that you measure energy use to actual energy use, because it is more generic and therefore it's more widely applicable. But would you say that was true?
Well, I think you're absolutely right in what you're saying. And if I speak to more seasoned engineers, they often ask the questions like, do we really need green coding? I mean, we have performance optimization. So where is the knob to tune if I don't take the classical performance techniques, right? And I think you mentioned some of the green coding techniques already. I think they are unique to green coding, like time shifting in particular. It doesn't save you any performance, right? It only saves you green energy, or saves you carbon emissions in particular. However, how we see it is that similar to like how you said it, if you think about green coding and there is energy now so widely available through many sensors, why not make it the first order metric? Because this is actually what you care about, right? You don't want to save on performance at the moment, or at least this is our mission. So you really want to save on energy. So why not take it, even if it strongly aligns or if it's strongly collinear with performance metrics in particular. So when these metrics are not aligning, there is typically something a bit wrong with your code in general. So there are energy anomalies where you see that maybe performance goes up or goes down, but the energy budget goes in the different direction in particular, which could be like misconfigurations, for instance. So you could have like there is something like a vector instruction unit in the CPU, nowadays called AVX. It was called MMX or SSE before. So also to get some gamers in the loop that might have heard these acronyms. They can be turned on, and then the CPU is using more energy, but actually it's not doing anything because it's currently not issuing any of these instructions. And this is typically a misconfiguration. So something turned this unit on, and then it's using more energy, and it's not needed, right? And it could also be that you have your hard disk misconfigured, like it's spinning all the time. It's not going into something like a sleep mode or a pause mode, or it can stop spinning the disks. Although you're not using the hard drive in particular, right? This is also in the whole discussion about idle time here comes into play. So your performance metrics could be perfect, but still the machine is on. So a green coding technique, a classic one, and this also is what our tool shows, is that if your code is doing nothing at the moment, like does it really have to be on? Maybe an architectural decision is here needed where you say, hey, maybe we move from a super highly coupled, highly integrated, vertically only scalable monolith to something like a microservice architecture that we can actually turn off between requests because we see more pause than we really see activity. So the node doesn't have to be on all the time. Why not use the energy or the carbon metric as your first order metric? And then if you lay hands on the stuff, you tune the performance metrics typically, right? But the measurement that you want to optimize against is the one that is actually following the goal that you want to achieve.
That's a great point.
Yeah, I do agree, especially when we know that we will more and more, as you mentioned, Arne, have to take into consideration embedded carbon and full life cycle carbon, etc. And maybe at some point, as you say, it will be environmental metrics and not just carbon, because we have other environmental impacts we do need to take care. And this is really the question of which machine shall I use, and sometimes using less powerful machine, older machine, is also a way to save carbon. But that opens a completely different debate.
It is a different debate, but it is worth reminding. There are three ways that the tech industry has to improve things. We have to it's not just code efficiency. It's not just be energy efficient. It's also about being hardware efficient, because hardware embodies one heck of a lot of carbon and time shifting. Those are the three things, and we have to do all of them. We can't just do one of them.
Yeah, I know. Recently, I was preparing a conference, and I just found again this amazing interview that Jerry McGovern did with Melvin Vopson. And I know this is a theoretical work. It's just, to raise alarm. But Melvin Vopson estimated the amount of mining that will need to occur to build the server to handle the 25% growth rate in data on a yearly basis that we have today. So plus 25% data equals that amount of servers to be built just to, manage it. And he discovered that in 2053, humanity will have to mine the equivalent of Mount Everest. So that's 175 billion tons, I think. just to build servers, just to handle the data. We're only talking about the data. And of course, then we can say, well, yeah, but we'll have energy efficiency, more efficient to etc. But the scale is still so amazing that it is something that we will have to pay attention to in a very near future. I know that at the moment we are focusing a lot on energy and immediate carbon emission because of electricity, but the embedded carbon is the next big battle. And actually it will be, I truly believe, the main battle at some point.
Yeah, and not just in data centers. Every time I have to throw away or give away or do something with a working device like a phone or a laptop because it's out of support, it's out of security patch support, but it works, and there's just so much embodied or embedded carbon in that device. It's immoral basically for us to know to kind of give up on providing security patches for work.
Yeah, that's true. That we need to remember that end user devices, they account for 3/4 of the entire environmental footprint during the manufacturing phase. I mean, not the building phase, and so mining, manufacturing, transport, etc., etc. So, of course, as professional in tech, we focus on what we can do, which is mostly data centers and networks. But that's also true that when you talk with designer, for instance, they are more and more aware of the trade-off between do I want to enhance my code, even to do green coding, versus how I make sure I actually reduce the size of my code and not create extra complexities that will accelerate software obsolescence and hardware obsolescence. So that's a very important battle as well. Can I ask you a final question? And that will be on best practices. And I know, Anne, that there are quite a lot of good and sound advices in your book. And Arne, you already touched upon them a bit, but if you want to comment, just feel free. But maybe Anne, as one of the 3 authors of the next O'Reilly book, what are the best pages?
Well, the introduction summarizes everything in the whole book, and that's already available in very rough pre-release form on the O'Reilly website. And you don't even have to buy an O'Reilly subscription, because you can just as O'Reilly say, you can do a trial and you can have a quick read of it. And eventually, when it's finally published, the whole book will also be simultaneously open sourcing, but not until it actually finally publishes next year. So all of that will be available. Yeah. So principles. This is a horrible thing. Nobody wants to hear this. No technology person wants to hear this. But really, the best practice is don't focus on optimizing your own code. Use code that's pre-optimized by somebody else, because that is by far the most effective thing you can do. In the long run, ChatGPT is going to become much better at optimizing code. Compilers are getting much better at optimizing code. So you try and push that job off onto somebody else, but do be thinking about architectures and designs that will work with time shifting. So things like spot instances and microservices where you can turn things off, as Arne mentioned, or you can time shift them. Think time shifting first is my advice.
Because you're influenced by your science fiction work. Like you want to travel across time, and this is why you're so obsessed by time shifting. That it is finally happening. What about you, Arne? Do you want to travel in time again? Also, sorry.
As I said before, I also think that time shifting will be one of the bigger gains in the future, and embodied carbon is one of the battles. I think one of the bigger battles to fight. Although there, I don't really know how the optimizations and this one will play out, because it's so opaque at the moment. Like most people don't even know how S3 is, for instance, implemented and what kind of hard disks. So it's very hard to say how optimizations could even work for a system like this, right? Which stores, I think, most of the data that the internet holds at the moment. I think my take on optimization techniques is very simple, so to say. So although we speak a lot about these particular very, as I mentioned some before, like these vector instruction techniques, etc., and these energy and performance metrics, anomalies. So we speak about them because developers like to hear these super funny edge cases where something goes horribly wrong. But I think for a daily business, if you really want to save energy in your code, most developers know how to do it. So there's really nothing you have to tell the developers really to do it. It's more like that they are overwhelmed. Business is not giving them the time and the support to do it. So I would really say that the key at the moment in particular is transparency. Like wherever you can, measure your stuff, even if it's not the best metric, and make it public. If it's on your own blog, if it's in the GitHub repository, or even if it's just in your notebook, that you at least know what your code is doing. And then the other thing is ask. Like ask your management for how much is our code emitting? Can you not give out these numbers? Ask the cloud providers, also something that Anne mentioned, which I think will drive a lot of the transition. Like you have to ask for these metrics. Like if for instance, if I go to the supermarket and I always buy a product and I'm always angry that it's not packaged in a recyclable paper, and I never ask the vendor like how I am thinking that something's going to change. Like there is no mind transition. I don't know what the English term for it is. Like something my mind goes into his mind, and he obviously knows that I'm unhappy with the product. I have to ask for it. So I think this is really at the moment the key. And these techniques like time shifting, there I really have to say, and maybe this is a bit of belly rubbing for you, Gaël, like hear podcasts like Green.io, because there you will hear about new techniques that developers find that are useful and should be employed.
Well, thanks. And that's a beautiful transition to my last question, which are, what are the main resources you would advise the developer community to go for when trying to green their code? But, Anne, you cannot mention environmental variable, because I'm going to do it first and give a big kudo to Chris Adams and Asim Hussain and the wonderful work they do with the regular guests like you. So environmental podcast, definitely a podcast to listen. I guess I'm listening pretty much every episode. So I've taken this one, so you need to find another one.
Well, of course, I'm going to mention my book. I'm going to mention my book. So, Building Green Software. So, and I have good reason for mentioning this, because we are publishing it every month. Ideally, hopefully, we'll be dropping a new. It's a rough early chapter, and we're looking for feedback. So, at buildinggreensoftware@gmail.com. Sorry. You'll be able to send us feedback for what you'd like to see in the book that is not already being covered. So if there are questions, if you're reading it and you're going, or I'm on Twitter, Sarah's on Twitter, Sarah's on LinkedIn, we're very happy to hear you come back and say, yeah, but I wanted you to answer this question. We will attempt to answer the questions.
I also pick up the question. So I'm monitoring a lot, apparently. Like the Google, I have Google alerts that alert me about new stuff that is coming out. I lead the Green Software Foundation newsletter. I read the Climate Action Tech newsletter. I'm an avid follower of this podcast. But I would say that there is no one resource. I think this is what you are kind of shooting for, Gaël. So there is no one central place where you can find the best information for it. But if I would have to name something that at least is a topic, I think that the most value I got so far in particular, and the most helpful techniques is like conferences. I think if people get a conference talk in somewhere where you have a sustainability track, this is already something that is a bit bigger, and this is to be watched at. So I think if you just want to follow one resource in particular, get an alert of something like sustainability conferences or sustainability tracks in IT conferences. I think there I've seen the most valuable content.
Well, that's music to my ear, knowing that we'll be in charge of the sustainability track both at API Days London and Paris this year. So that's okay. I've got like a big blessing from you. Thanks a lot. But that's so true. That conferences are they're cool. I mean, you can interact, you can discuss with your peers, and that changes everything, I guess, from like being just a passive listener. And I know, unfortunately, I didn't aim for a single source of truth. I'm always a bit dubious with these approaches. But that's great, actually, that you mentioned it, because we tend to mention articles, podcasts, etc. But yes, conferences. And the big fight made by the Green Software Foundation, I mean, they've got a speaker repository now. And I know that their approach is like, no conference today in tech can spare having a sustainability track, or at least some talks on sustainability. And I think that's a great approach. And I've like gathered people from all over the world saying, hey, these folks, and as far as I remember, both of you are in this on the speaker bureau, but these folks, and I do as well, full disclosure, but yeah, these folks, they can talk, and if you cannot find anyone, then just connect with them, but you cannot have like a big conference without someone talking about carbon, sustainability, and so on. So it makes definitely a lot of sense. Well, thanks a lot, both of you. That was a very lively discussion. I really enjoyed it, and just letting you answer to each other, that was really music to my ear. So I'd like to thank you once again for all the feedbacks and insights that you shared with us today. And once again, thanks a lot.
Thank you, Gaël. It was great to be in the show.
Thank you very much.
And that's it. Thank you for listening to Green.io. Make sure to subscribe to the mailing list to stay up to date on new episodes. If you enjoyed this one, feel free to share it on social media or with any friends or colleagues who could benefit from it. As a non-profit podcast, we rely on you to spread the word. Last but not the least, if you know someone who would make a great guest, please send them my way so that we can make our digital world greener, one bite at a time.